And it is how I arrive on YouTube. Hi everyone, welcome to my channel. In this series of videos, I'd like to show you how I designed this go-kart. I also walk you through how you can design your own using Fusion 360. I, with my boys, built almost the entire go-kart on our balcony, without any welding, just using basic tools, which I will show you shortly. In this first episode, I'm going to show you how I designed the main board, steering wheel, steering system and front axle. As I mentioned earlier, part of a series, so if you'd like to follow along, feel free to subscribe so you don't miss the upcoming episodes. I'll try to upload the next one as soon as I can, but I have a day job and 2 sons, so please be patient. The best part about this build was that I made it together with my sons. They helped me drill holes, cut sheets, screw in bolts, paint and do plenty of other things. I encourage you to do the same. Build a go-kart together with your kids. For me, these are some of the best memories I have, working side by side, building it together. In the description, you will find a link to a Google Drive folder containing the drawings, a list of materials used so you can calculate the cost of the go-kart and a list of the tools. Feel free to use them. And lastly, sorry for my English, I'm not a native speaker, but I hope you will still enjoy the ride. If you have any questions, feel free to leave them in the comments. I'll be happy to answer them. Before we dive into actual design, let's go over the essential tools you will need. First up is the drill. Not only will it serve as the power source for the go-kart, but we'll also be using it for drilling holes. I bought a Metabo drill because it comes with a charger and 2 batteries. Having 2 is a key. When the first one runs out while the kids are riding, I can simply swap it for the second one and keep going. The set also included a small tool workshop, wood drill bits, metal drill bits and screwdriver bits and other things, because we will need them too. This tool workshop was the perfect choice for me. We'll also need a wood saw, a metal saw, an Allen key set, sandpaper, files, a set of regular wrenches, paintbrushes and paint, and of course a workspace and at least some kind of workbench, although I used my old box on the balcony. In fact, I did most of the work out there as I don't have a workshop or garage. These are truly the essential items we can't do without. Other tools are optional and can be skipped if necessary. For example, a jigsaw. Not strictly necessary, but it allows for more precise and clear cuts. When we design the steering wheel, I will show you the difference between one made with the jigsaw and one made only with the handsaw, drilling and filling. Another useful item is a vise. I bought one later and mounted it to the box I mentioned earlier. Also wood glue and an M6 tab. You will need the tab, if you decide to make one specific steering wheel component, which I will show you today. If not, you can skip it. All tools is mentioned in the sheet which is available on the earlier mentioned Google Drive. Links in the description. One last thing, like I mentioned earlier, I did most of the work on the balcony. However, there were certain parts that I had modified by more experienced craftsmen. When ordering those components, it was possible to request the modifications directly. It was an extra cost, but the precision was well worth it. You can also modify them yourself if you have the tools and the confidence, or you can have someone more experienced to do it for you. It's up to you. So that's all for the tools. Now let's finally move on to Fusion 360, where I will show you my design process. We will start with a baseboard measuring 1500 by 450 millimeters. I used a board from an old school desk that had been discarded at our school. While detaching it from the steel frame, I discovered some old hardened chewing gum stuck to the underside. Nice, thank you students. I drew the position where the wheel would rotate, as well as the cutouts needed to allow the wheel to move freely. I choose the dimensions of 150 because the wheel has a radius of 130 millimeters, and I added 20 as a clearance. For securing the wheel's rotation, I used an M8 bolt, which required drilling 2 8mm holes. In the attached Google Drive file, you will find a simple 1:1 scale drawing with name basic board drawing for print and cut. If you print it on a regular printer and cut it out, you can easily trace the exact spots where you need to cut and drill. I used a wheel with a diameter of 280 mm. I downloaded a 3D model from grabcad.com. If you want to create your own build, the link is provided in the description. Inside the wheel, a mounting sleeve is inserted, which has an outer diameter of 20 mm and an inner diameter of 13, making it a good fit for an M12 threaded rod. An M12 washer with a larger outer diameter must be used on the rod to prevent the mounting sleeve from slipping out of the wheel. A lug nut should also be used to ensure the wheel doesn't fall off. At first, I didn't use one and the nuts kept losing during the ride, so we ended up driving around and collecting parts all over the parking lot. On the opposite side, a wider washer is also required for the same reason. Behind it, I placed two regular M12 nuts to increase the clearance between the wheel and the baseboard, preventing them from rubbing against each other. Next, the part I called the wheel holder is inserted. This is the piece on which, unsurprisingly, the wheel is mounted. I used a wooden block that I had available, but of course you can adjust the dimension to suit your needs. From the top, an 8 mm hole must be drilled for the bolt that enables the wheels to paper! In the attached Google Drive file, you will find a simple 1:1 scale drawing named Front Axle Wood Drawing for Print and Cut. The procedure is the same as before. If you print it on a regular printer and cut it out, you can easily trace the exact spots where you need to cut and drill. From the side, another hole must be drilled. Be careful to ensure that it does not overlap with the hole for the wheel rotation on the baseboard. This hole should have a diameter of 12 mm to allow the M12 threaded rod to pass through. Now you can see how I slightly refined the wheel holder to make it look better. Let's move on to designing the tilting system. The marked hole shows where the bolt M6 will go, holding a simple aluminum tube, or you can say spacer, with a diameter of 10 mm and a height of 10 mm. The mentioned aluminum spacers were cut to size from a 1 meter piece I purchased, and they will come in handy later as well. In total, I made 4 of these spacers, since we will be needing them shortly. It is important to countersink the bolt head so that nothing obstructs the wheel rotation or the sliding of the wheel holder under the baseboard. For the steering system and the overall build, I took inspiration from several YouTube videos, but most of all from one made by the Garage 11 channel. The link is provided in the description. However, one thing I wanted to change was the positioning of the steering mechanism. Garage 11 placed it on top of the baseboard, which prevented full use of its length, since the driver's legs could hit the tilting system. As the author himself wrote in the video description, if building now, I would make it bigger. For this reason, I decided to place our tilting system underneath the baseboard. An advantage of this design is that the pedal can be moved forward, so as the kids grow, it will still be adjustable, allowing them to drive comfortably. The pedal solution will be covered in another video. To secure the spacer, I used a lock nut. It's also a good idea to place washers on both sides to prevent the tilting mechanism from slipping out through the nut. I actually forgot to draw one washer. Finally, on the front axle, M8 washers are inserted where the wheel holder will pivot. Without them, the friction between the baseboard and the wheel holder would have been significant. After that, the entire front axle is attached to the baseboard with a bolt, and it can now tilt. Once the left side was completed, I simply copied it to the right side. That's when I realized the two sides weren't symmetrical, so the solution was just to rotate the tilting system by 180 degrees. To prevent the wheels from tilting inward or outward, I add a connecting plate. I use plate with dimensions 420 by 60 by 15. The dimensions of this plate are up to you, but they has to be less than width of a basic board and more than the split between holes on the board. Don't say. I used a narrow piece from old furniture with a keyhole. Once again, I used washers and lock nut to ensure the joints don't loosen over time. Finally, I choose M8 carriage bolts because I like how they look. So, while we watch assembling, I want to say that my main goal of all this is to motivate parents to spend time with their kids. I mean, when you calculate it, thanks to the sheet in the Google Drive, you can cheaper buy plastic motorized toy car and give it to your child just like that. But the value of spent time is priceless, and you will be also proud on you when you accomplish it. I promise. So that is the reason why I'm doing this and trying to remember it when I'm totally demotivated because my English in this voiceover sounds horrible. So if I motivate one of you build something with your kid, I will be totally happy and satisfied. So if you build something, please leave a comment. I will really happy to see it. Also, if you need any help during build or designing, just leave comment and I will happily reply. With this, the front section is complete and we can now move on to the steering wheel. When designing the steering wheel, I first had the boys sit on the baseboard, approximately where the seat would be located. Since the steering wheel was the second thing we made, very first thing we built was the sign at the front of the go-kart. I handed them the steering wheel and measured the distance from the front of the board horizontally and from the board's surface vertically. I marked this point in Fusion and drew a line to the support plate, which allowed me to determine the angle at which the steering tube would be inclined. Once I had this angle, I created an auxiliary horrible word plane in Fusion at the given slope and sketched the projection of the tube. I use an aluminum pipe 20 mm in diameter and 1 mm thick. Using this sketch, I cut a hole into the baseboard. With the same sketch, I extrude the aluminum pipe and insert it into the drilled hole. Now, we finally move on to designing the steering wheel. First, I created and saved a new component in Fusion 360 named steering wheel and inserted a linear coupling SHF20, which I downloaded as a 3D model from GrabCAD. This coupling is attached with a bolt to the aluminum tube we worked on earlier. This steering wheel is one of the parts I'm most proud of, mainly because it's mounted with this coupling using only 2 bolts and wing nuts. This makes it very easy to swap, so each of my boys can have their own steering wheel. We even made one for a neighbor's friend. I think it's a pretty cool gift. The design of the steering wheel itself is entirely up to you. I chose this racing style version simply because I think it looks great. Now I want to show you why it's great to make a 3D design first and only then start building things in real life. As you can see, when I immediately place the wing nuts here, they collide with the coupling. So something had to be changed. The first thing I tried was cutting short pieces of aluminum copper tube, 10 mm wide, buying longer bolts and using them as spacers. But this turned out to be very impractical. The tubes kept falling off while changing steering wheels. After a while, I came up with the idea of simply cutting away the part of the coupling where the collision occurred. And that's exactly what I did, as shown here. However, once I had cut it and mounted everything on the go-kart, I realized that all I actually needed to do was rotate the coupling by 180 degrees. So much for my designing skills. So yeah, 3D modeling is a great tool, but relax, stepping aside for a while often works even better. But definitely I'm recommending to design it first and then start to build. Again, I used carriage bolts because they look good and kids will not scratch on them. As I promised, here are photos of my boys' steering wheels to compare 2 methods of cutting them. On the left is our first one, where we cut the edges with the handsaw, and the middle holes were made by first drilling holes along the outline and then filling them. It's okay, but a bit rough. The one on the right was cut with a jigsaw, much smoother. Once the steering wheel was finished, I attached it to the aluminum tube inserted into the baseboard. Then I continue with the design of the tilting system. For some background, the original tilting system I made was from wood. After the first test rides, still without the drill powered drive, without the drill, I was pushing while the boys were driving, the wooden part cracked. That's when I decided to go for a metal solution, which I designed as follows. I used a linear coupling SK20, which I mounted on the bottom end of the aluminum tube. The drawback of placing the steering tilt mechanism under the baseboard, unlike the Garage 11 design, is that it cannot be one straight piece. It would have to be very long, and when driving over bumps, it could catch on the ground and tear off. Therefore, it needs to be bent at an angle. Here is how I solve it. An aluminum plate cut at a 45 degrees angle is inserted into the coupling. It is then fastened to the coupling using M6 tooth lock washers, bolts and lock nuts. I made this part from a scrap piece of aluminum plate, but you could use any suitable material. This is the first of the parts I mentioned earlier. You can either make it by yourself or have it made by someone else. I made mine from an aluminum plate I had. The cut with a handsaw was far from perfect. Then I drilled holes into the 45 degrees surface, spaced so the aluminum piece could be attached to the SK20 coupling. The holes had a diameter of 6 mm. Honestly, I drilled them even worse than I cut the plate, but it didn't matter in the end. Finally, for this part from the other side, I drilled two holes with their centers 5 mm from the edge and a depth of 25 mm. You can go deeper if you need or like. Then I tapped them with an M6 thread, as deep as my tap would allow. I personally recommend asking a local mechanist if they have time to make this part for you. Another option is to use an online service. This is not a paid promotion, but as an example you can use jlccnc.com. On the website you upload the 3D model of the part. It's available on the Google Drive under the name steering aluminum part.step. First select your region on currency, then choose from the options provided, the material, then specify type of material, whether the surface should be machined, no need for that I think, tolerance, how precise the part should be, surface roughness, smaller number, bigger precision, bigger price, so it's up to you, and threads. I would use these settings. Here you decide with the threads. If you want to cut the threads yourself, click no. If you want the part delivered fully finished with threads, click yes. In that case, an upload window will appear where you can submit the drawing, which is also stored on the Google Drive under the name steering aluminum part drawing.pdf. There is also a .dwg version with the same name, depending on which format you need. Next, confirm that you don't want the sub-assembly. Select the number of parts. So if you need one, just click one. In the description, you need to fill in the category. Click irregular shape category, then others, and in the box write something like steering system for Go-Kart. Finally, choose the delivery time and submit your order. The payment and checkout process I believe you can easily handle on your own. So let's go back into Fusion 360 for the final assembly of the tilting system. We will use the same spacer tube as for the wheel holders. As I mentioned earlier, we need a total of 4 pieces, and now is the time. Just to remind you, the diameter is 10 mm and the height is also 10 mm. The last component we will use is a turnbuckle eye to eye. I used an M8 turnbuckle, but since it wasn't available in Fusion, I selected a 7x16 inch, which had an inner eye diameter closest to M8, which I used. Assembly is very simple. You take an M6 screw, add an M6 washer, then the aluminum spacer, then the eye from the turnbuckle, and finally screw it into the aluminum part. Repeat this process twice. In Fusion, finally I'm simply showing how I measured the correct spacing between the eyes to make sure it's set up properly. So in this video we looked at the tools we will be using, designed the baseboard, mounted the front axle, designed the removable steering wheel, assembled the tilting system. In the next video we will pick up right where we left off. We will add the seat, mount the rear wheels, design the gearbox and secure the rear wheels. If you don't want to miss the next video, I'll be really happy if you subscribe. Thank you for watching and I hope to see you in the next video.